Hey guys, so today we're going to take a look at a really cool programming problem from LeetCode, which is to find the index of the first occurrence in a string, right? The problem statement is given that we are provided with two strings, an entire string and then a second string. We're supposed to find out the first occurrence of the second string in the first string, right? So for example, here we have sad but sad, and then we have sad here as a second string. And we're supposed to find the first occurrence of uh, the second string inside the first string, right? So the entire substring must be there in the first string. So for example, here we were able to find second string in just the first position, right, in zeroth index. So we will return zero. But we should also take a look at this because like we are able to find another instance of the same word, but at a later point in time, the string, right? But we're not going to take that. We're just going to take the first occurrence and then return the index. But in this case, lead code and the second string is lead O. We were able to find lead, but we were not able to find O. So we basically did not find the second string inside the first string. So in this case, we'll just return -1. So that's kind of the way, that's kind of what the problem is about. And the way that we solve this is by using two loops. So we would be iterating, we will have one loop which kind of iterates the outer string, the first string, which is the haystack. The basic idea of using haystack and needle here is that we need to find the needle inside the haystack, right? The way that we do it is that we have one iteration which kind of iterates the haystack string from start to end, and then whenever we find that if the first character or the iterating character is the first character of the needle, we enter into another loop, and then we'll iterate through the second string and the first string at the same time. And for example, here we have SAD, but SAD, right? Uh, when we iterate the first element, we find that S is the first element of the needle, and then we go into another iteration, and then we iterate through the next element A, and then we also iterate to the second element, second string needles. So we go to the A there as well, and then we go to D here, and then we go to D here, and at the end, if we did come to the end of the second string and we were able to find all the strings, we'll just return the index of where we started the second iteration, right? So that's kind of the way that we solve this problem. So I'm gonna code this out in Java. So the very first thing that we need to do is we need to declare two character arrays, which kind of has both strings as an array, so it will be easier for us to iterate through it. So is stack dot toString to character array, then character array of 1, which is kind of the second string that we receive. So yeah. Now we are gonna code out for some base conditions. So a few of the base conditions are really interesting because there may be cases where needle's length might be greater than the haystack length. So in those cases, we won't be able to find needle, right? So needle has a higher length than haystack, right? So that doesn't make sense. So I'm gonna code that base condition in. So I'm gonna check if array of 1 length is greater than array.length, right? So in this case, I'm just going to return -1 because that's not possible at all. There's also other cases where if array1.length is equal to 0, meaning that we don't have anything to start with. So in this case, I'm just going to return 0. So the idea is that if there's no needle at all, right? The then it and then that it would mean that we would just return 0, right, in this case. And that's kind of the base conditions. I don't think there's anything else other than that, so we should be good to start. So we're going to type out the first iteration, which iterates to the haystack string. So int I is equal to 0, I is less than dot length, standard. So this is the first iteration that we do, and we are going to check for one condition, right? Out of the iteration, right? So we're going to check if I is equal to array 1 or 0. So why 0, right? So we are iterating through the haystack string, and when we iterate through the haystack string and find that one of the characters in the haystack string is the starting of the middle string, we go in, we check for that condition, and then we go into the second iteration from there, right? So before we go into the second iteration, I'm just gonna declare another maybe start index, I guess, and then I'm gonna declare it to I. This is because we want to store the index that we are starting to iterate from, right? So I'm gonna do another. I'm gonna create another pointer here, and then we'll do a while loop to check if j is less than array. So j will contain the pointer when we iterate to the second string, right? So one dot length, and then one more check that we need to do is we need to make sure that I is also lesser than. We want to make sure that we have not crossed the I limit, right? So that is there, and then so inside this we have to check another we have to check the same condition again, but this time we are going to use j instead of 0, and then if when we're iterating through both these substring, if both these characters are equal, we'll kind of move them along at the same time, right? So I plus plus j plus plus, and I suppose we'll have to have another condition as well. So if it is not equal, if at a point in time, if for example we have the second character as x or something else, right? So in that case, we need to break out of this loop, and we will need to get started from have I get started from here again, right? We've iterated thus far, and then this is not the substring, so we need to start from here, and then we need to check again and check for the first string again, and then we need to do the same thing again. So so that's kind of another reason of storing the start index. So we'll just set oops right to start index, and then we will do a break. Yeah, so when we're iterating through the substrings, right? So in this case, we have sad and sad. We've iterated through sad and sad, and if we have reached the end of the needle string, we will need to return the start index from there, meaning that say we are comparing S and S, and then we are incrementing I and J, and then we comparing A and A, and then we are incrementing, since they are equal, we are incrementing I and J, and then we are at the end, right? So we're comparing G and T, and then both are same. In that case, we'll have another condition which kind of checks if we are at the end of needle, and so far it's been the same. In that case, we need to stop the iteration right there because we found the string in haystack, and then we would return the position that we started out the iteration, right? Second iteration. So I have another condition here which kind of checks if j is equal to air dot length. So yeah, so in this case we can just return start index. So that's kind of pretty much it. So if we are not able to find anything, we could just return -1 at the end here. Um, so I think this should run. So let's see. Oops, we have an error here. My bad. So I'm supposed to check if we've reached the end of the second string, not the first string. So I think that might be the issue here. Yep. Let's submit and see if we are able to pass all test cases. Yep. So we were able to pass all test cases. So that's kind of the idea, guys. It's fairly straightforward. We just have two iterations, and then if you find that the character, if at any point a character is just it contain the same character as the starting character in the second string, we kind of go into another iteration and then we check every character. If we find it, we return it. If not, we start back from the next character and then we do an iteration again. So thanks for listening. I'll see you again tomorrow with a new problem.